Adding with integer chips. Integer chips are models that we can use to show how integers are added and subtracted. There are two kinds of integer chips, positive and negative. We see positive and negative. And for our purposes, each integer chip represents one unit. So this would be one positive unit, and then this one would be one negative unit. Do you remember what a zero pair is? A zero pair is two integer opposites, meaning that they have the same absolute value or the same distance away from zero on the number line. For example, if we put a point at positive 1 and then a point at negative 1, we can see that these are zero pairs because both 1 and negative 1 are 1 unit away from 0 on the number line. 1 and negative 1 also add to 0, making them zero pairs. The most important thing about using integer chips, especially when we're dealing with adding integers that have two different signs, is that a positive integer chip and a negative integer chip are 0. So our positive integer chip is 1 unit positive, our negative integer chip is 1 unit negative. When those are combined together, when they're added together, they equal 0. Let's add two integers that have the same sign. So if we fill in all these integer chips with negatives, okay? So this means we're adding integers that only have negatives. Both integers that we're adding have the same sign. So if we count up the integers, we have 1, 2, 3, 4, 5, 6. 6 negative integers, which would be negative 6. And then we're going to add to that 3 negative integers, negative 3. So we can write an equation that looks like this: negative 6 plus negative 3. And we can solve that simply by counting up all of the integer chips. 1, 2, 3, 4, 5, 6, 7, 8, 9. My answer is 9, but we have to make sure that we keep our answer negative because all of our integer chips are negative. If all of our integer chips are negative, then that means that our answer must also be negative. Let's add in two integers with different signs. Let's model that with integer chips. Let's put negatives in this top row of integers, and let's put positives in this bottom row of integers. Now, what if the question asks to write the addition problem that is modeled by the integer chips? What we would do is begin counting. So we would count the top integer chips, 1, 2, 3, 4. So we have 4 integer chips that are negative. So that means we have negative 4. On the bottom, we have 1, 2, 3, 4, 5, 6, 7, or 7 integer chips, which are positive. So if we want to write the addition problem, we have negative 4 plus 7. Okay? Now what we talked about before was a negative and a positive integer. A negative and a positive integer chip cancel each other out. And the mathematical name for those are zero pairs. So let's circle all of the zero pairs that we have in our equation. And we can see that we have 4 zero pairs. So let's cross those out because we don't need those anymore, because all of those integers just add to 0. So when we're adding integers with different signs, our answer is always going to be the integer chips that are left over. So we have 1, 2, 3 integer chips left over. Those integer chips are positive. So my answer is 3. Let's practice some others. If I'm going to draw integer chips, the first thing I should think about is that I have two integers with the same signs. Okay? If I have two integers with the same signs, that means I'm going to be counting all of the integers associated with both of these. There will not be any zero pairs if the two addends have the same sign. So if I take -4, I can draw 4 negative integer chips. 1, 2, 3, 4. And then I'm adding another -6 or 6 negative integers. 1, 2, 3, 4, 5, 6. So if I add these all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I get an answer of -10. All I had to do was add up all my integers because I had no zero pairs. The next problem, 4 plus -6. Now I have integers with different signs. This means that we're going to be looking for zero pairs. So if we draw our integer chips, we have 4 positive integer chips, and we have 6 negative. Okay. So what we can do is we can go ahead and circle our zero pairs. Remember, a zero pair is a positive integer chip with a negative integer chip added together. So we have 1, 2, 3, 4. I can get rid of all of these zero pairs because they just add up to 0. There's no reason to look at those anymore. Our answer is going to be what's left over, and what's left over are 2 negative integer chips. So the answer to 4 plus -6 is -2. Let's review. Integer chips are used to model integer addition. So we have positive integer chips and negative integer chips. Each one of these integer chips represents one unit. This one represents one positive unit. This represents one negative unit. So when these two integer chips are added together, they equal 0. That's why these are called zero pairs. When you're adding integers, you need to identify if the two integers have the same sign or different signs. This is a key part of using integer chips. If your integers have different signs, then there will be zero pairs. These zero pairs cancel each other out. So if we have 5 positive integers on the top, adding to 3 negative integers on the bottom, we can cancel out our zero pairs, which would be these 3 pairs. And we can go ahead and cancel those and cross those out. So our answer is always going to be what is left over when you have two integers with different signs. So in this example, our problem is 5 plus -3, and we count the number of leftover integer chips, which is 2. So we know that 5 plus -3 equals 2. A key concept here is to understand that if we have an integer addition problem with integers that have two different signs, your answer will always be the number of leftover chips. What's going on, baby? Are you bored out of your little baby mind?
Marvin stated that John appeared to have been high on some drugs himself that night.
The 30-foot fall ruptured Davina's liver and spleen, but according to the autopsy, it didn't kill her.
I think that is probably one of the hardest things for me to swallow, is that he could have saved her.
And he left her for 2 days to rot like a piece of garbage. And he told no one. And he just left her there. So if he's not guilty of anything else, he's guilty of knowing that she was there and didn't try to help her.